In this example, we want to evaluate the limit as x goes to 0 of cos x minus 1 all over cos squared x minus 1. And this is an important example because it emphasizes two paths we can go down when it comes to using trigonometry in calculus. So the first thing that people tend to do when they see this kind of exercise is reach for the Pythagorean identity, sine squared x plus cos squared x equals 1. So then with a little bit of rearranging, we can see that cos squared x minus 1 can be replaced with sine squared x. But note that that doesn't actually get us anywhere. Say we replace this whole denominator with sine squared x. Well, we can't cancel anything with the numerator, and when we plug in 0 for x, we still get 0 over 0, so it's still an indeterminate form. So this example shows that a trig identity, while useful, is not always the best way to evaluate limits, and indeed a lot of other exercises that will come up in calculus. So what else can we do? Well, note that we can factor this denominator into cos x plus 1 times cos x minus 1. So that's the second path when you see trigonometry in calculus, is if a trig identity doesn't work, try factoring and see if you can get that to work out. So let's do it. So this is the limit as x goes to 0. We still have cos x minus 1 up top, and now the denominator becomes cos x plus 1 times cos x minus 1. We're just factoring that out. And then look at that. There it goes. So we have simply the limit as x goes to 0 of 1 over 0 cos x plus 1. And now we can simply plug in 0 for x. Remember, cos of 0 is 1. So this is 1 over 1 plus 1, so 1/2. So while trig identities are wonderful, don't always rely on them as the only way to work through these exercises in calculus.